All right, now we're going to do section 12.3. In section 12.2, we looked at the surface area of cylinders and prisms. So 12.2 was surface area of prisms and cylinders. 12.3 is surface area of pyramids and cones. And so a prism has, just refreshing on a prism has two congruent bases. And just a reminder, the bases are just one thing to always keep in mind with prisms. The bases are not necessarily the shapes, the faces that are on the bottom and top of the picture, how it's laid out, how the prism is laid out. The prism is the two faces that are congruent and parallel to each other, and then the rest of the faces have to be rectangles. So, we saw in the last section sometimes those prisms were laid on their side, so that instead of the bases being the top and the bottom, the bases were the front and the back, or the left side and the right side. So just, again, I just want to emphasize, pay attention to that when you're doing the prisms. Pyramids, on the other hand, have only one base. And usually that base is on the bottom. Doesn't have to be. We could turn a pyramid on its side, but usually just it's easier to set it on its bottom, on its base. So more often you'll see pyramids with the base being on the bottom. Granted, think about if you have something that's pyramid, you could flip it and put it on a different face. That doesn't change where your base is. It just changes the way that your pyramid is laying. So for a pyramid, you have your base. Your base can be any shape. And then you only have one base. The remaining sides are triangles. And those triangles are slanted to where they all come together at a point. Think about Egyptian pyramids. If you have that visual in your head, you kind of have an idea of what a pyramid is. And that type of pyramid is what it would be referred to as a square pyramid, because the base is a square. So whatever the base is, that's the type of pyramid it is. And then we're going to focus on regular pyramids. So there are other ways that we could draw our pyramids, but we're going to focus specifically on pyramids where the base is a regular polygon. It might be a regular triangle, it might be a regular quadrilateral, which would be a square, but it's regular, meaning that the sides of all the sides of the bases are all the same. And then we're going to make sure that it's called an oblique pyramid, where it's kind of tilted on its side. So what that means is they're going to be right pyramids, which means that the tip of the pyramid, the top of the pyramid, is going to be right directly above. If you drew a line from that point straight down to the base, had to be perpendicular to the base, it would go right through the center of the base. So what that would mean, what that's going to cause, is that's going to cause all those triangles on the sides to all be the same shape. Okay, and again, we'll look at that when we actually kind of break these down. So when we're looking for the surface area of this, all we have to do is we have to find the area of the base. Let me get there it goes. The area of the base, and then we need to add to that the area of, we call the lateral triangle. So those are the triangles on the side. There might be 3 triangles if the base is a triangle. There'll be 4 triangles if the base is a square. Again, think of the pyramids, the Egyptian pyramids for a visual. and just add those two areas together. You just have to make sure that if there's 3 triangles, you find the area of all 3 triangles, not just one of them. Which, since we're looking at regular pyramids, all 3 of those triangles would be the same size. So you just have to find the area of one and then multiply it by however many of the triangles there are. The other thing we're going to look at, which is a similar type of shape, is cones. For cones, you have, if you were to draw the net of a cone, you've got your base, just like you do with a pyramid. You have one base. Because that base is circular, you end up with more of a sector instead of triangles that form that point. And so if you were to try and unwrap a cone, cut it up and unwrap it, this is what it would look like right here. Then to find the area of that, the surface area of that, you've got pi r squared. The pi r squared is going to be the area of that right there. And then pi times r times, this is L. That is going to tell you this. L represents the lateral height. Okay? And if you haven't already looked at it, I've also posted a video that kind of explains in a little more detail, kind of demonstrates the difference between height and lateral height in terms of pyramids and cones, because that's going to be a key thing that we're going to look at, depending on when we're doing surface area or where we're doing volume, determines which of those two heights we want to look at. And so if you haven't already, it would be a good idea to check that video out to make sure that you know the difference between the two and understand when we have to use which. So for the surface area, we're focusing on lateral height. So that's the slanted height, the diagonal height to the side, as opposed to the straight up and down height. And again, watch that video and that'll explain a little bit more. And so down here I have, sometimes we aren't given the lateral height, sometimes we're given the regular height. And we'll have to use stuff from chapter 7, either Pythagorean theorem or our trig ratios to find that lateral height. Or when we get to where we need the regular height, if we're given the lateral height, we might need to go the opposite direction as well. But again, you go ahead and check out that other video where I show and demonstrate the difference between height and lateral height. But let's go ahead and get started with our surface area. Okay, so find the surface area of the square pyramid. So first I'm just going to really quickly draw out a net for those of you who liked seeing that, if that helped you with your surface area, like we did with the prisms. If I were to just cut along all these tops that go to a point, it would look like this. Our base is 16 by 16. So it's 16 here and 16 here. So that part we can figure out the area of without too much difficulty. It's a square, so it's going to be 16 times 16. That's going to be the first part of our area. But then we have to add to it the area of all of these little triangles. 1 triangle, 2 triangles, 3 triangles, 4 triangles. Now, because this base is a square, these triangles all have to be the same size. Okay, so really what we need to do is we just need to find the area of one of those triangles and divide by 2. Times by 4. And the area of one of those triangles and times by 4 will tell us the area of all 4 of those triangles. And to find the area of a triangle, we have to take half of base times height. Now, this is where we have to pay attention to that difference between the height versus lateral height. Okay, when we're talking the area of this triangle, we need the base of this triangle times the height of this triangle. Oops, didn't want that. Times the height of this triangle and then divided by 2. Okay, but the height of this triangle right here is not the same as the height of the pyramid. And again, if you haven't already, I'll explain and show a little more visually why that is in that other video, showing the difference between the height and the lateral height. This height right here is actually the slant height, or the lateral height, which is along here. Okay, but in this particular instance, I'm given the actual height from the tip of the pyramid straight down to the middle. And if you draw those, you can kind of see that it's forming a right triangle. There's the base. And because this goes from the center down to smack dab in the middle of this this square, that means that this distance right here has to be 8. Okay, because the whole way across the square is 16, so half the distance across the square is 8. So now I have this right triangle here, and this is 15, this is 8. I need to know that slanted height, which would correspond to that height. So we have to use Pythagorean theorem in order to find that slant height. Okay, so here's the area of the square. That's that red part that I mentioned before. But to find the area of each triangle, we need to find that lateral height. Okay, so as I mentioned, we need to do, here's a picture of just that. So we use Pythagorean theorem. So 15 squared plus 8 squared equals our c squared. 15 squared plus 8 squared. And then divide that by, or not divide, sorry. Take the square root of that. It's going to give you your c. So we end up with our c being 17. So that's this side right here is 17. Okay. Now that we know that that height is 17, that slant height is 17, we can find the area of this triangle right here. Because we know the base of this triangle is 16. The height of this triangle is, we just figured out, was 17, because that's that distance right there. And so half of 16 times 17, because to find the area of a triangle, it's half of base times height, so half of 16 times 17 is equal to 136. Okay, so now we know that this square is 256. The area of this square is 256. The area of one of my triangles is 136. And so now I just need to combine that and make sure that I don't just count one triangle, but I count 4 triangles. So I'm going to take the 256 and I'm going to add to it, I need to take this 136 and times it by 4, because that would give me all 4 of the triangles. So I'm going to take the 256 and add to it this 136 times 4. So here I have the 256 and I'm adding to it the 136 times 4, and we get 800. So the surface area of this square pyramid is 800, and because our units were, I'll backtrack just to the picture again, we can see our units is centimeters, and since we're finding surface area, our units has to be centimeters squared, because we're talking about an area. Remember, anytime it's an area, it's going to be squared.